Good morning, everyone. So we're here to talk about stealth addresses, and the usual start of such a talk is to understand who in the room has used stealth addresses. Not a single person. Which is great, because that's why we are here, to give an introduction to stealth addresses, but also to discuss why so very few people use it, especially in a room with a sophisticated audience like this, and what can be done to improve this, because this is perhaps the most pragmatic way to increase adoption of privacy tools in, not only in Ethereum, because stealth addresses predate Ethereum by a long time, as we'll see, but across the overall crypto ecosystem. But before we start, who I am, so I'm Hugo. I work at ScopeLift. We are an engineering studio based out of the US. We have a banner outside with my Telegram QR code if you want to reach out later. We do mostly EVM engineering with a focus on privacy and governance, and we work with top projects. So we typically work with Uniswap, Optimism, ZK Sync, Tally, but also other infrastructure projects such as Obol, Wormhole, and so forth. I started working in crypto in 2017 at a centralized exchange in London. Back in 2019, we did the world's first institutional grade Bitcoin bond with an European bank that was regulated by the FCA in the UK. But I guess that was too soon. No one cared about Bitcoin bonds back in the day. We crashed and burned. I moved to DeFi. Then I was doing policy lobbying, so crypto lobbying, for 3 years here in Portugal. I ended up with a bunch of people here in Portugal writing Portugal's crypto tax law, which is perhaps the reason why so many of you are in this room today. And then I worked in crypto cybersecurity at Immunify, and now I'm at ScopeLift. So that's my path. And I really believe crypto is great, and it's really important to solve the world for the better. And that's why I like to build cool stuff that enables that. But typically, this cool stuff that enables that takes so much time to reach mainstream adoption. And that's what we are going to discuss today. Because complacency is all around us. Everyone is talking about privacy since the dawn of time, basically. But very few people use privacy tools, as I was mentioning. Now I'm going to ask you, and I'm going to remind you that the cameras are not pointed at you, so you can raise your hand. We're in the room as use Tornado Cash. Samurai, okay? The Samurai guy was arrested here in Lisbon, but I arrest you. You can rest assured I'm not going to snitch you out to the FBI. Again, not many people. Yet, many people, when they are asked, they claim that privacy is very important to them. But then, when they act on the day-to-day, it is proven by empirical experience that they are not indeed very focused on actually using the privacy tools at their disposal. And this is what's called the privacy paradox. Okay? And there's a lot of debate about whether the paradox is actually a paradox, or is it more of faulty argumentation logic in regard to whether or not it's mostly about that people care about privacy in certain contexts, but not all contexts, but then they are just bad at communicating their preferences. But one thing is true, that people indeed communicate that privacy is important to them, although I didn't ask you that question today. But then a bunch of friction in the real world impacts how they are able to enact their preferences. And so there's this very famous study that was, maybe you have heard about it, designed in the MIT in 2014. This is when they gave a bunch of MIT students $100 back in 2014. So maybe you have heard that story. And they had a bunch of experiments, and it was mostly about trying to understand whether or not design and other obstacles in the user experience impacted the way people selected more privacy-friendly approaches to them. And this was important because there's also a bunch of privacy regulation, and because if people say they care about privacy, product managers and designers are going to try to design for their preference, right? But then if people don't actually use that, they're just wasting time, or then they're just doing their job wrong. And what was found is, the usual thing that is pretty much straightforward, is that if there's an incentive for you to avoid privacy principles, for example, disclosing private details of your friends. For example, if someone pays you something for that, if someone gives you extra yell for that, it's very likely that we are going to fall for that. And so positive positive incentives will very likely change the way you value privacy and value the privacy of those around you. And then conversely, on the other end of the spectrum, if there are helpers, if there are ways that people try to use to make you a more private conscious user in the moment, for example, by disclosing information about how secure is my data and how different wallets provide different privacy features to you, then what people see is that more important than these disclosures and more important than the help that designers try to give you to be more private is just simply the ranking of the options on the page. So simply the pure physical visual design of something will have more friction than the cost of you like going through the knowledge and considering all those choices in your head and making the more rational choice, assuming your preference for privacy is indeed key. So privacy paradox is quite interesting, and now that privacy, as Pedro from Wallet Connect was saying yesterday on the last panel, is the last mile of crypto, as A16Z said on a tweet and on a blog post this week, is the biggest moat for 2026 for all the builders out there, especially for chains. I think it's very important for everyone to have a deep understanding of like what's at the core of the issues with privacy and why privacy adoption is so slow, given the fact that people say they like it, but then they don't. So with that, this is another survey that I was mentioning. With that introduction, let's begin and let's talk about stealth addresses. To talk about stealth addresses, we need to understand that the privacy space, and I'm going to show an EVM slide right now, but this extends to other ecosystems as well, is quite broad, okay? And eventually quite dark as well, just because it's private, joke, but it's also quite difficult to navigate due to its complexity. And there's so many different technologies that are being developed right now, and that's super exciting. But again, as with so many other developments in the crypto space, we really need to be careful about not getting lost in the intricacies and the beauty of R&D work and be focused on what actually is shipped that comes to production and is adopted, used by us on the other end of the spectrum. So yeah, privacy, especially on Ethereum, is a complex landscape. This is a very recent mind map that Vitalik has famously espoused and is being mostly advocated for by the PSC, the Privacy Stewards of Ethereum group, which is now the Ethereum Foundation group, kind of tasked with building most of this stuff to make Ethereum as private as possible. Is very complex, okay? And within this complexity, there's a bunch of stuff that we're not going to touch today. Some of the other talks are about that. We are just on the top ballot, on the top section. And within the top section, we are just focused on the stealth addresses. Again, we have shielded pools, we have other types of pools, we have mixers, and stealth addresses are a different subset. And they can be used in conjunction with the others, but not necessarily. And now with this, you are going to understand where stealth addresses lie in the space and how they pan out. But again, the message here is that currently the Ethereum development ecosystem for privacy is naturally very much focused on R&D, because especially if we go back to the other sections of privacy that you can see here, there's a lot of R&D that needs to be made. Everything is being built as we speak. But at the same time, going back to the beginning, if users claim they want privacy, then we need to figure out what can we offer them so that they can be safer, so that they can be used, and so that crypto can continue its path to mainstream adoption. And perhaps more importantly than the users themselves, what is another big trend of 2025, 2020, even earlier, but very critical now? That's naturally institutional adoption, and not just mainstream consumer retail adoption, right? And for institutions, privacy is of the essence, just due to the nature of their business models and due to the nature of the sensitive data that they handle. And so if Ethereum wants to be like the credible, neutral infrastructure for TradFi coming on chain, then it needs to solve for privacy on that level too. And for that, R&D is definitely important, but on the side of the apps, that's what we're talking about today. And why this context again? Because many people think, oh, stealth addresses, that's not sexy. That has been around for 20, 30, 40 years. So I don't need to use it because I don't need to, I don't even, due to the pseudonymous characteristic of blockchain, since the beginning, I've never even used transactions in a way that are my privacy, because by design I knew it, and so I was just avoiding that. But then, sometimes people make mistakes, and they reveal their identity, and there are so many ENS addresses out there with so much problematic information associated with them. And this is why this is so important. This is why outside of the R&D, simple, pragmatic implementations of stealth addresses are so important. But so then, the question remains, what the hell are stealth addresses? And to put it very simply, stealth addresses are just disposable addresses, okay? Think like a PO box that is used one time, a disposable email that some people use when they want to sign up for dubious websites. And in the essence, that's just that. It's just a way for people to very easily, very conveniently, with great UX, generate one-time use addresses. And that's pretty much that. Of course, there's a lot of nuance to it. And for example, one of the more important aspects that I want you to come from this presentation is the fact that stealth addresses protect transaction recipients, and they can protect the sender, but the sender needs to want to be protected. Typically, because the sender will initiate a transaction, they should be sophisticated enough to protect themselves through the protocol, but not necessarily. But in any way, at least the recipient is protected, and that's key, because like if suddenly you got $1 million in your ENS for some reason, because a very generous donor decided to gift you something nice for Christmas, then everyone will see that, and you might get mugged on the street and attacked with a wrench. So this is why stealth addresses are quite elegant and interesting. And the more interesting thing about that, but at the same time, the more, not controversial, but problematically interesting thing about that is that the idea of stealth addresses is so very old again. Conventionally, we like to say that it was born in 2014 with Peter Todd advocating with a clear implementation of stealth addresses for Bitcoin in the Bitcoin mailing list. But before that, in 2011, Bytecoin, a user on the Bitcoin Talk forum, had already, in very rough but complete terms, described such an implementation as well. But eventually, this all goes back to 1976 and to a particular elliptical curve algorithm, the Diffie-Hellman, that first conceptualized how this can happen. So just to see how long things can take between research and very clear research with everything that's needed to be implemented to actual production stuff. And so this is the origin of stealth addresses. And the context of this is to see then for everything else that's being developed, expect a long time for things to come to fruition. And then in 2020, after 2014, after this was not necessarily already implemented, but yeah, firstly implemented in Bitcoin, Monero also used this, other chains also used this. Vitalik was like, okay, Ethereum will benefit greatly from this, and so it will be time for stealth addresses to come to the L1 and be used. So these are key for the EVM, and someone should build this. And what happened was that this was at the very start of COVID. There was that first ETH Global event that was fully digital back then, and Ben, the founder of ScopeLift, and Math, another co-founder that now works at Optimism, shipped Umbra's Alpha during that ETH Global hackathon. So this was the first implementation of stealth addresses that on Ethereum that came to life. And for a long time, it was the only. Right now, there's a bunch of cool players, a bunch of very nice projects building more on that, for example, Fluid Key, and even building other implementations. But this was the first. And it took a while, it took like roughly 1 year to get grants and to bring this vision then to mainnet. So the demo was naturally just a testnet thing, attracted some interesting attention. I think it reached the semifinals or something. And yeah, eventually it came live through the generous support of many people through Gitcoin, but also, for example, Metacartel, the Ethereum Foundation itself, has gave a bunch of grants, Unstoppable Domains, and a bunch of individuals that just cared about privacy And they put their money where their mouth was and funded this through Gitcoin. So this was the start of self-addresses on Ethereum. And since 2021, it has been a reasonable success. Again, this is a non-profit project. The only fee that is charged is an anti-spam fee. That's not collected by the protocol. There's no plans whatsoever to monetize these. It's a public good, and the goal is to stay like that. But still, has reached interesting adoption. And on that red line over there, that's when Tornado Cash was banned. And as you can see, there was big increase in adoption at that time. But now it has plateaued. And we have been thinking about why it has plateaued. We have not reached any particular conclusions. The protocol add a V2, as you'll see later down the line in 2024, so with much better UX, much nicer features. There's much more attention to privacy right now than before, but still, it plateaued. Is this because people are transacting less on-chain on a mainstream consumer level? Is it because most of the activities is DeFi-based and institutional-based, and people have their identities protected some way? We don't know. It's something interesting to discuss. Happy to chat about that later. And then the question remains, why are self-addresses so cool? Well, they are non-interactive, and that's good UX. And the key point here on the non-interactive part is that I can create a self-address for you, and you don't need to create it. And I send you the funds, and then you'll be able to access the funds without having created a self-address. Okay, as long as I create a self-address in the right way, using another wallet of yours that I know about. And so that's quite interesting, and that's quite one of the most important barriers that has been overcome in this regard. And then, of course, the implementation of this is all that matters. But then, as I was mentioning earlier in the presentation as well, it is also like a very pragmatic solution. It's not super sexy. It's not going to change the entire privacy landscape, but it's used, it's simple, and it's very modular. And mostly, like there's some argument to be made here that it can incentivize then further R&D in regard to what can be then investigated on the margin on other areas of privacy that are tangential to these. And this that you're seeing on the screen is just a map of all the things that PSC group, the Privacy Stewards of Ethereum group, is researching right now. And sorry for that, something broke when the PDF was downloaded. So yeah, it's good that pragmatic solutions are used, even if they are not perfect, because it incentivizes people to use adoption. It allows people to understand why adoption is not, why privacy is not as well adopted as we were talking about, and then this will bring better research forth so that people can build better products. And now they have been standardized in 2 ERCs. This happened in 2024, and it's a key step because it allows everyone to build on top of these. And one of the addresses is mostly an implementation for anyone to just be able to even use another encryption protocols on top of the self-addresses concept on the EVM, and the other is that method registry that allows people to then very easily be able to receive the funds without having created the self-addresses themselves. Okay, and this is not only on mainnet but on a bunch of L2s. And these are the RRCs, and again, they are important because mostly they allow this interoperability on the one end, and also because they just facilitate everyone to speak the same language, and this is where all the other projects starting to come from. And in addition to FluidKey, a bunch of new projects have been building on top of these with ZK proofs, with different user interfaces. So the Umbra protocol can talk with other projects that are working on self-addresses, and no one needs to use one or the other. Everything works seamless together. And yeah, this came in July 2024, and it came with the SDK as well. So it's very easy for devs to just add these to their wallets, add these to their projects. It's really quite straightforward, and there's a very nice documentation page that you can access. It's selfaddresses.dev, and so it's very much simple to go and check. Again, why are self-addresses not used as much as they should, as we were chatting about? First, they are unlinked. I think I deleted that one accidentally. And they are not necessarily untraceable. But even on the unlinkability aspect of self-addresses, the fact that someone, an external observer to the blockchain with self-addresses, won't be able to see the link to your funds, even though you control both wallets, both your public wallet and the self-addressed one. But you need to do it right, okay? There was this recent study from 2024 as well that specifically checked on the Umbra data, and they more or less saw that roughly half of the people using Umbra, and these have been 95,000 individual users, were able to be traced or linked. So this is bad. People are using something with expectation of privacy, but then, like, when they receive the funds on their self-address, if they send the funds to another address that they control publicly, it may be then linked. And there are many techniques for that. These guys even identify more heuristics than these four, roughly 6. The study is linked there. I'm running out of time, so I can't go into detail on these. But if users are not sophisticated, if they transact at the same times every day, if they transact with certain patterns, then that unlinkability will be broken. And so it's even important in these pragmatic solutions to continue to do research on how to educate users further and how to nudge them to make sure that they are able to use the tool in the most effective way. To conclude, what's the path forward for self-addresses and beyond? So that, as I mentioned earlier, Umbra v2 was launched, and was launched last year as well, with more grants from the Ethereum Foundation and some other folks. It's very much focused on solving these problems, improving the UX, helping users to understand how healthy their self-addresses are, and how healthy their self-address actions, such as the withdrawal of the funds from the self-address are, as you can see on the bottom right corner. And of course on the UX and on interoperability, working with a bunch of wallets, and this was all enabled by those ERCs that were written by some members of the Umbra team, some Ethereum Foundation researchers, and Vitalik himself. And so in the end, Umbra is just a bridge for a world with native privacy. It's just this pragmatic tool that eventually will fade away totally into the background. And all that matters is that all these privacy tools are totally embedded in a seamless user experience. That's what we want to build for. That's what we are excited about. And that's what we want to chat about with any privacy builders out there. Happy to collaborate. Conversely, on the other end of the spectrum, it's not only about design and UX and convenience. Privacy builders also need to care a little bit about regulation and about policy, because privacy will only be adopted if it's allowed by the regulators. Of course, like as a crypto builder for a long time and as a former lobbyist, I very much know that crypto tech exists to fight against existing regulations and to force the regulators to change. But at the same time, for builders that are doing commercial products, they need to be attentive to regulation, and they need to care that they are working in a way that protects their interests if they are building something for profit. And in that matter, compliance, there's a huge fit between compliance and regulation and privacy, and many jurisdictions love privacy, but policymakers are damned clueless about the power of privacy tools and how they can be embedded in the existing legal systems to make something that's really nice and something that really works for everyone. And so there needs to be all this education, and for example, Marina from UCI is doing a lot of that as per the talks yesterday, and this should also be something on the mind of every privacy builder. Lastly, there are other untapped opportunities in this space. I was just talking about payments, because that's kind of the beginning of everything in crypto. But even though there are also alternative solutions to some problems in crypto that are not payment related and that require privacy, such as voting, other governance actions, gaming, and messaging, and so forth, it is also the case that, again, while we are creating those very complex, sophisticated solutions that may take a lot of time to come to fruition, we can start using very pragmatic solutions to solve for that. And self-addresses can very neatly already be implemented for self-DAO voting, which can be quite important. For public goods funding, which is also quite important, and that's already enabled, and on-chain messaging, as I was mentioning. And eventually other use cases that we are working on with builders to enable and make them cool. And with that, we conclude our presentation. Not sure we have time for questions. I believe not, but I'll be around all day, and I'll be happy to chat privacy with all of you. It's, again, the last milestone or for our industry, and we really need to make it work, or else we are all doomed, especially with the state of the world right now. These are my contacts if you want to reach out, and yeah, thanks for listening.